Hi everyone, this is Mrs. Lee. This is Poly Wog lesson 3. It's on page 225. Technically it should be M1 225 in the purple book. This is going to be the last lesson, lessons, and it's going to be on Poly Wog. That's going to be before the unit test. All right, for the do now, remember it was just sketch cubics, one with 1 0, 2 zeros, 3 zeros. All right. And we found one with 1 0 looked like this, where it just crosses just one time. Or it could look something like this, where there's just that inflection point right there, and it just crosses at one time, right? Again, these ones could be lower, or not lower, because that would be 3 points, 3 roots, but like it could be down like this, or it could be up like this. Either way, it does not matter, as long as it's crossing the x-axis only once. And then 2 roots, we have one like here. This one right here is like a double, it's not like, it is a double root. It's a double root, and then it goes right through for that second root right there. And then here we have a standard 3 roots, 3 real roots. Yay. All right, and our, what is it? Our learning target for today is just the one. Generalize about the key characteristics of polynomial functions. Okay, just key characteristics. Tomorrow we're going to do the other stuff. Absolute maxima, absolute minimum, and the extremas. We're going to talk about that right now. So we're going to skip a couple of pages. We don't got time right now. All right, so this is on page 229. And relative, so there are 3 different things that you need to, or 3 different things that you need to be highlighting. The first one is the relative maximum is the highest point in a particular section of the graph, functions graph. It's called relative because relative to the other points around it, it's the highest one. So if you notice right here, I made a little graph right here. You can draw that as well, if you have not already. And notice right here that we have 2 relative maximums or maxima, right? And so one right here on the left and one on the right, right? Think of them like hills. They have 2 hills, right? And it says right here the relative minimum is the lowest point in a particular section of the graph, not of the whole graph, just of that in that region, right? So this one is called a relative minimum right here. Note it can also be called the local minimum and local maximum. Some books and teachers say that because it's localized to just one specific area. Okay. Then the other thing to highlight, if you notice they're bolded, right? The absolute maximum is the highest point in the entire graph. So we're looking not just in the local area, like worldwide kind of thing, right? The whole world. Right? Are you best in the whole world or just best in the region, right? So this one right here on the left, that is the absolute maximum because that is the highest point this graph is ever going to go. It's never going to get any higher than that. So that's what we call an absolute maximum. And for this one, in this case, we actually have no absolute minimum because there is no lowest point, right? This is a relative minimum. That does not mean that it's the absolute minimum because as you notice right here with the arrows, it keeps on going down, right? So there is no lowest point. So we just say no absolute minimum. Okay. And another thing that was a student had brought up, and absolute maximum can also be considered a relative maximum. Usually only the more significant label of absolute maximum is used with the term relative minimum implied. So if you're an absolute maximum, that automatically implies that it's a relative minimum, relative maximum. Okay, so you don't have to be like, oh, it's an absolute maximum and a relative maximum. It just is. It's like saying, oh, you're the best in the whole world. That assumes that you're going to be the best in your area, right? Because how could you be best in the whole world where you're not even the best in your area, right? Or in your region, or in like relative to the people around you, right? So that's kind of implied already in that. All right, we're moving on, going forward. Skipping. Yep, all that skipping. All right, so now we're on page 234. So now that you flip to it, and we're going to take a look at a few things here. So we're looking at cubics, which is x to the 3rd power. So anything with x to the 3rd power as its highest degree, and quartics, where x is to the 4th power, and that's the highest degree. You could have other things afterwards, like plus 3x, minus 1, whatever it is, right? And then quintics is going to be x to the power of 5. So this is a 5-degree polynomial. Okay, and let's see here. There's a couple of different things. If you notice right here, I color coordinated them. So these are just all possible end behaviors, right? So what are the arms going to look like? right? Not what it's doing here in the middle, right? Does it go up and then we don't care about that. All we know is when X is really big, what is Y doing, right? When X is really small, what is Y doing, right? And if you notice right here for the cubics, you have one arm up and one arm is down. It's always going to be that way. All right, and why is that? If you take a look at x cubed, right? And if we put in a big positive number, right? Like positive 100, okay, that's pretty big, right? Cubed, right? What are we going to get? We're going to get a really big we're going to get a really big positive number. We're going to get 1,000,000, okay? So now, but if we did like x cubed and then we put a negative 100 in here, like a pretty big small number, pretty big negative number, right? And then if we do that cubed, and that's going to just be the exact same number, except what are we going to have? One more zero in there. It's going to be negative, right? So that's why on the negative side, it's always going to be negative, and on the positive side, the answer is always going to be positive. All right, and so that's why one arm goes to the left. So if your A is positive, it's going to go down low, and it's going to go down and then up. So your arms are looking like this. I don't know if I can do that. All right. So, and same thing if we flip-flop it, right? So if we say that this is going to be the negative of that, right? It's going to look very much like this, like number 2, if you look right over there, where it's going to just reverse. So these two signs are going to reverse because it's the negative of 1,000,000, which would be negative 1,000,000, and a negative of a negative 1,000,000, which is a positive 1,000,000, right? So everything gets flipped. It goes this way now, right? So that's kind of like the arms that we drew. Okay? So that's what a cubic would in general look like. As x approaches positive infinity, f of x approaches negative infinity. Positive infinity, as we go more to the right, we go down. The graph goes down. All right. And then the possible number of x-intercepts is, we learned last time, right? The fundamental theorem of algebra is that if this is to the third power, the highest number of roots we can have is 3. Like we did quadratics, the highest number of solutions we had was 2. It was either 2, 1, or 0. And 0, we knew that was just imaginary numbers. So same here. Possible numbers, we can have 3 real roots, 2, or 1. So when we talk about roots, we're talking about the x-intercepts, okay? X-intercepts in specific, right? So we have either 3, 2, or 1. And if you notice right here, graph number 1 shows us the 1. And graph number 2 shows us 3. And graph number 4 shows us 2. And, you know, the third one does. All right, so those are the 3 possible ways that it could intersect that x-axis. All right, and then a possible number of extrema. Extrema, oh, we didn't talk about this before. It was in the previous one. Extrema just means it's the combination of minimums and maximums. So I'm asking you, how many minimums and maximums do I have? Instead of saying that, because that's a really long sentence, we could say, how many extrema do we have? And you would say, well, let's take a look here. So there's 1 here and 1 here. So there's 2. 1 here, 1 here, 1 here, 1 here. Could it ever be like not 2? Can we have like a 1? We can't have 1 because if we go up, we're going to have to at some point go back up again. So we can't just go down because it can't, that's not cubic. It'd have to go back up again. Okay. So note that you can have none, right, where it's always increasing, where there's just that inflection point right there. Okay. So that's the, so it's 2 or none. And always increasing, again, it looks exactly like this. I drew these pictures just because it's easier to relate to and understand, at least for me. And so here we have the always increasing, where it's just that inflection point where we're not actually like going straight across, but it's like always just gradually, this like here it's like gradually increasing at this inflection point, but it is always increasing. And then always decreasing, where we just literally just flip it, right? So it's always decreasing. And then, sorry, that's not supposed to be a bump right there. That looks kind of like there's a bump there, but that's not supposed to be. It's supposed to be like inflection point. Ooh, that's not good either. I will figure it out. There we go. Something like that. All right, and then once it's increasing, decreasing, increasing. That's literally what it's gonna look like. I just do it with my hands. Increasing, decreasing, increasing. So it's gonna look something like that. And when is it decreasing, increasing, decreasing? Just like that. So it's just literally just flipped. All right. So then we went into groups to kind of talk about like the different possible ones for quartics and for quintics. just know when we have quartics, let me go into group. Oh, here's 4. All right. So if you notice right here, look at group, this one right here. Oops, sorry. We have arms that are both up and arms that are also both down. Either they're both going to be up or they're both going to be down, right? Because remember, if it's x to the 4th power, all the negatives in there become positives, right? It's just like our quadratic, how both arms were up. It's the same kind of thing here. Either both arms are up or both arms are down, okay? So, yeah, so always for our end behavior, we're always going to have the same thing on the very end. So if you notice right here, as x goes to positive infinity, f of x goes to positive infinity. Notice right here that either they're both going positive or they're both going negative. Okay, that it's always either arms up or arms down. This is my arms up and arms down. Okay, and because again, we don't care what's happening in the middle. We want to know what's happening at the end. That's why it's called end behavior, not middle behavior. Okay, end behavior. And then the possible number of x-intercepts, 0, 1, 2, 3, and 4. Right, those are the 4 possible ones. You want to take a look back here. Notice right here, there's like literally no x-intercepts here, or like 0 x-intercepts. Here, how many do we have? We have 1, 2, 3. So we have 3 x-intercepts. And here we have, remember, 1, 2, 3, 4. So this is 4 x-intercepts. If I could write x-intercepts, and here we have 2 x-intercepts. Oh wait, did we ever do 1? Can we do a 1? Yeah, right here. Look, right here. There's a 1. 1, just like that. Double root right there at -1. Right. So that is going to be, so those are all the different possibilities. Notice because we have it in either the arms are down or the arms are up, it is possible to have that 0 x-intercepts, as opposed to when we were over here at the cubic. Since one is up and one is down, right? It's like this, right? It will always at one point cross the x-axis at some point. Okay, so that's why we will never have no x-intercepts. It's not possible. All right, and then for the quintic ones, also possible intervals of increase. If you have both arms up, you have to have at least one turn. You can't not have a turn, right? Because they're both going up. So let me get here. So number of possible extrema is going to be either 1 or 0 or 3, not 0, 1 or 3. So what do I mean by that? So we need at least to turn once, right? To go, an arm to go up, to go back to up again, right? So here is, so we could go, let me see. So if I'm just looking at the up ones, so either we're going to have something like, looks like this. So that's like 1, where we have one turn and then we have like an inflection point, or we could just do like the standard one right here, where we have 1, 2, 3, right? Count them. How many mins and maxes? 1, 2, 3. That's 3 extrema. Okay, so we're either going to have 1, just the one right here, or we're going to have those 3. We're never going to have 2 or 5 or 0. We at least have to have 1. All right, so that's the extrema or extrema. And then possible intervals of increase and decrease. So I didn't want to write down increase, decrease, increase, decrease. So it's just, here it is. Okay, follow along with me. So it's going to be decrease, increase, decrease, increase. It could be like that. Or it could be like increase, decrease, increase, decrease. Right, and then here, this is my attempt at inflection points. So it goes decrease, still decreasing, and then increase, right? Up, right? Or we have the increase, decrease, and still decreasing. Okay, so it's just increase and decrease, right? Kind of like how it would be for a polynomial or parabola, okay? But except this has a little bit of a different kind of decrease. All right, so those are the 4 different things that you could do, okay? So here it is. So we have all possible end behaviors for quintics. So if you notice right here for quintics, let's go with group 3. All right, so quintics, we have, notice again, arms either up and down or down and up. Okay, it's one or the other. We're not going to have both arms up or both arms down, very much for the same reason as we would a cubic. All right, So we know that arms are up and arms are down. So again, we're going to take a look at that end behavior. And again, please notice, just like how we did before. So these are always going to be opposite. They're always going to be one's minus, one's plus. Okay. Or the other one is going to be, again, one's plus, one's minus. The ones, it's always going to be the opposite way, always for the arms. All right. And then for the number of possible x-intercepts, again, since it's quintic, we can go all the way up to 5. We cannot do 6 because it's not possible. We only have 5 possible answers, okay? And then, so it's a possible number of x-intercepts is 1, 2, 3, 4, and 5. Remember, we cannot have 0 just because one's going down, one's going up. At any point, we will have at least one of those, what is it called? It'll cross the x-intercept, or x-axis, sorry. And then the number of possible extrema, right? So that's going to be 4, 2, and 0. And if you notice right here, right? So here's the extrema. So here's 1, 2, 3, 4. So there's 4 bumps, I guess, bumps, hills and valleys, right? And you can get, like if you look at number 15 right here, you got, let me just mark it down right here. So we have 1 down here and we have 1 up here. So that's 2. Okay, so that's like 1 going, we're turning, and then we have that inflection point and we're going down. All right. And then we can have one, and I don't think I have one on here. No, I don't. So let me just go over here. So if you look right over here on the right-hand side, that one is possible where you just have these inflection points like that. And that would be your, so we would have no extrema. It's just continually decreasing. All right. And so that would be the same for all these. And I'm not going to go into all the different kinds of increasing, decreasing on that part. Just know that important part is one arm is up and the other arm is down. Okay. So it does, we don't know which way. That has to do with end behavior, and it has to do with, you know, the actual function, but we'll talk about that in a bit. So we're going to move on. Okay, we're going to go to 12. Okay, so we kind of take a look at 12, and we're like, okay, so determine the a value of this function. Okay, so first of all, one arm is up and one arm is down. Actually, like this, right? Which means we automatically know it's an odd function. How odd, right? And remember, if we're putting in negative numbers in for x, right? That means that this is all, the result will also give me a negative, right? Because we're talking about an odd function. So it's like x to the odd number power, right? So let's say if it was x to the, you know what? Let me just show you. Let's go back. So if you're looking at, this is an odd number. If you look at the coefficients here, right? You notice the number in front of the leading coefficient, right? -1. Notice that's a negative, and notice where the arms are. This one is on the left, it's up, right? Notice this one is positive, and this is down. Over here, this is, again, negative, which means this goes up. This is also negative, which means this goes up, right? So the left arm is up when it is a negative coefficient, a leading coefficient, right? Which is our A. So we're going to go back and we're going to be like, oh, it's down, which means that this is definitely going to have to be positive. So it's positive because the left arm is down and the right arm is up, all right? The degree of this function is odd, right? Because one arm is down, one arm is up. It's always opposite for the odd ones. And then let's take a look here. Can this function be a cubic function? And we're like, no. Why or why not? Because, so remember, we have how many x-intercepts? 1, 2, 3, 4. We have 4 x-intercepts, right? And the cubics can only have up to 3 real roots, okay, or 3 x-intercepts. Okay, that's all we can do. Okay, and the domain and the range, we didn't get to this for some classes. The domain is going to be our x values. So what can x be? If I were to pull this graph all the way to the left, right, keep on going to the left, would I be able to find a point on the graph? And you'd be like, well, yeah, but it'd be really, really, really like low on the graph, right? Like, because do you see how steep it is already? Yeah, we can still find one because notice it's still going a little bit to the left, keep on going left. So we will be able to find a point. It'll just be very, very big negative number, right? So it's going to go all the way from -infinity to, well, can we do the same thing on the right-hand side? As long as this arrow is not pointing straight up, which it's not, it's just slightly tilted, right? So that means it's still going to the right. Not a lot to the right, but it's still going to the right, which means it's going to go to positive infinity. So that's the domain. Remember, that's kind of talking about the x's. And then now we're going to talk about the y's. Well, how low does this go? And if you notice, this arrow goes down, which means, yeah, we're going to go to negative infinity. Well, how far up is it going to go? And if you notice again, it's going to go up, right? It keeps on going up, which means it could be anything. So do positive infinity. So the range is from negative infinity to positive infinity. Remember, we put those brackets in there because we're actually not going to, what is it called? We never get to negative infinity. It's like not possible, like really. So there we go. And so now determine the number of relative extrema in this graph, right? Extremas, remember those are the mins and maxes or the hills and valleys, right? We got 1, we got 2, we got 3, we got 4. So we have this many, 4, right? Now determine the number of absolute extrema, right? Do we have an absolute highest point and absolute lowest point? No, because we have the arrows, right? We got an arrow going down and an arrow going up. Plus it's an odd function. And so, yeah, that's not going to work. So we got none, like none. All right. And then use estimation to identify the intervals where the graph is increasing. Remember, we're going from left to right. So increasing is going to be, I'm going to use purple for increasing. So remember with increasing, we're talking about our intervals of x, the x interval, right? Not the y, right? So we don't care how high it goes. We just want to know where is it increasing, right? So it's from negative infinity all the way up until, let's say, negative 2.5. So it looks about there. So, oh, come on. So from negative infinity to negative 2.5. And remember, at that highest point, it's actually not increasing or decreasing, right? So that's why it is not including. And then another time when it is increasing, and it's going to be from like this -1 all the way to like 0.4, 0.3, maybe 0.3. So -1 to 0.3. So that's another increase right there. But let me do that in purple, just right there. And then also this is going to be the last increasing right here, right? So that's going to be from 2.2. I want to say 2.2. So 2.2 to positive infinity. That's where it keeps on increasing. So 2.2 to positive infinity. Those are all the intervals where it is increasing. Decreasing is all the other ones, right? So decreasing is going to be from, we have 2 of them. We got one right here and we got one right here. So that first one is going to be, right? So we said that was going to be negative 2.5. So from negative 2.5 to negative 1, right? So basically it's all the stuff in between. So negative 2.5 to negative 1. And then here's the other part right here, right? It's in between 0.3 and 2.2, right? And if you remember, right, we had said that was going to be about 0.3, 0.4-ish, right? So I said 0.3. And then all the way down to this point right here, which is 2.2-ish, right? As long as you're not putting like, oh, 7. That's not close to 7, right? Remember, we're looking at just the x values. We do not care how high and how low. A lot of people still get that wrong. Okay, we're just talking about these intervals, looking at the x's. All right, so now try this yourself. Okay, so press pause and try it yourself. All right, you better be back from pressing pause. All right, so if you notice right here, determine if the a value of this function is positive or negative. For me, I like to figure out first, is this an odd or even function? So I know what I'm dealing with, right? So I get a better picture in my brain, and I'm like, oh, both arms are pointing down the same direction. And if you remember, that is definitely an even function. I think of like parabolas, right? Parabolas had both arms pointing in the same direction, either both up or both down, either like this or like this. Okay, so it's even. So now it's pointing down. So since they're both pointing down, we know that this is definitely, it's going to be some negative. So the a is definitely some negative value, whatever, -2, -1, negative something. Okay, so it's going to be negative because it's pointing down. All right, now, can this function be a 6th degree polynomial? Well, let's find out. How many, so we look at how many zeros we have. 1, 2, 3, 4. Well, like, yeah, it could be, it could be. To tell you a little tip, if you see the number of turns, you could actually tell how many, well, not exactly, but it could help you with that, right? The number of turns is 1 less than whatever the degree is, right? So if you're like, hey, here's 1 turn, 2 turns, 3 turns, 4 turns, 5 turns, that means that this has to be a 6-degree polynomial at least. It could be like 8, but it's at least going to be a 6-degree polynomial. Okay, but yeah, it could be. So yeah, yes, yes, because it has 4 x-intercepts. Intercepts, which is less than 6. And why am I choosing 6? Remember, because it could have up to 6 intercepts, right? X-intercepts, but it could have less than that. Okay. All right. So let's move on. All right. State the domain of this function. Domain, how far to the left and how far to the right. And if you notice the arrows, they're still going a little bit to the left and a little bit to the right, which means x can be anything. It could be whatever you want, as long as it's within negative infinity and positive infinity. All right, it just can't be imaginary. All right, state the range of this function. Now this one, I see the going down part, but there's no going up arrow, right? Which means it does have an absolute maximum. So at this point right here, so this point right here, that's as high as it's gonna go. So that's about like at 2.4, 2.5, let's just say 2.5. All right, so it's gonna go all the way. Remember, we state the lowest point first, so all it goes from negative infinity to 2.5. That's as far, because remember we're talking about how high it can go, right? So that's that's the cap. Okay, that's the ceiling. There's no more. So it's going to be at 2.5. Done. So determine the number of relative extrema. Remember hills and valleys. You got 1 hill, 2, 3, 4, 5. So there's 5. Oh, that's a terrible 5. 5. So determine the number of absolute extrema. Okay. If you notice right here, we just have that one right there. So this one is the absolute, because that's how high it's going to go. That's it. Absolute max, we'll say. And we'll just have 1. That guy right there. That's it. Okay, there's nothing higher. And so that's why this is a relative of a maximum, but it's not the, what is it called? Absolute maximum, because it's not the highest. It's the way it goes. Do we have an absolute minimum? No, because we have these arrows that go all the way down, right? That's much lower than any of these points. All right, and then we're going to use estimation to identify the intervals. So let's go, intervals. So we'll go with the purple again. So this is, I'm just marking my intervals. So 1, 2, 3, those 3 intervals right there. So it's from all the way to negative infinity. Remember, we're looking, negative 8, not negative 8. All right, we want negative 8 fell down, right? And broke his crown. Okay, I'm just kidding. All right, so we're going to go all the way up until negative, what is that, 2.7? So about negative 2.7. All right, and then we're going to increase again right here. So it's going to be from, where is it? Remember, we're looking at just the x values right here. So it's about negative 1.5 all the way to, when do we stop? It looks like it's a little bit after the 0, which is like 1.3, or no, 0.3, I should say. So 0.3. And then the last part of increasing is going to be from 2 to, I think that's a little after, before 3, 2 to 2.9, we'll say. So 2 to 2.9. All right, remember none of them are square brackets, because none of them are equal to, because remember right at that top point, that's neither increasing nor decreasing. It is doing one of these, right? So that's that. And then we're going to go with the interval of decrease right here. Boom, just like that. Boom, boom. All right. So we're going to try these out. So remember these points, we already have those points for these points right here. So it's just going to be negative 2.7 to negative 1.5. And then between these two guys, is going to be just kidding, 0.3 to 2. All right, because remember the in between the increasing intervals are the decreasing intervals, so we can use the same points, right? That's what we did here. So in between these two numbers is going to be the decreasing. In between the 0.3 and the 2, that's going to be the decreasing part. All right, and that's it. And tomorrow we'll talk more about this stuff. All right, I'll see you guys later. Have a good one.